Okay, welcome to our last section of notes for this unit. So this is our very last lesson. After this, we're going to start taking a test. So we have one like day that's listed in that calendar. Remember, not in your Google Calendar, not in your Schoology calendar, but there's like a spreadsheet that has a calendar that says like what each day is going to be, and it's labeled as a fluff lesson. So we're going to spend that time talking about IAs and really get the ball rolling on IAs. We're going to have a review day in class. You have a review packet. It is up on Schoology available for you, as well as the answer key for that review packet. You also have a review on Cognigy. If you would like to have a review that's like more IB, like kind of tough questions, it's really good to quiz yourself on really, really tough things because that way when you get to the test, it's really easy. So you've also got a Cognigy review available for you. So we'll have a review day in class where you can work on the review packet, you can work on Cognigy, we'll answer questions and work through that, and then you have a test. So that is the plan, just letting you know what's on the horizon. So this lesson in particular, we were talking about different ways to measure central tendency and spread. So remember that central tendency is your mean, median, mode type of stuff. And then after that, we're saying, okay, well, we can talk about what the central tendency is, but what we really care about is like, okay, well, where is the rest of our data? How does it spread out from there? And so we talked about our 5-point number summary. We talked about our range and our interquartile range in relation to our median. So it really gave us a full picture visually. We have our box and whisper plots. So it gives us a visual representation of what's going on with our data. And now we have something else that you see a lot when we talk about statistics, which is this phrase or term, standard deviation. Standard deviation tells you how clustered the data is around the mean. So this means, and it's all relative, right? So if you get a standard deviation of 5, for instance, if you're talking about a total range of 100, a standard deviation, like a percentage, right? If I said, hey, your average for the test was a 75, and if the clustered or like the interquartile range was pretty much between 70 and 80, saying that your mean was 75 is a pretty good representation. So sorry for those of you who are visual. Um, having a, let me get a spare piece of paper, having a mean of 75 when your interquartile range is between 70 and 80 is a pretty good representation when you have so standard deviation is this symbol. So if you have a standard deviation of 5, that means that you're pretty much on either side of 75 by 5 points. So that's a pretty good representation, right? So a standard deviation of 5 is pretty good if you're talking about a large range. If you're talking about a range between 0 and 10, right? If I said, okay, well, the average on the test was an 8 out of 10, but, so if I said an average was 8 when your standard deviation is 5, that means that of the full range between 0 and 10, 8 was your mean or your median, and then having on either side 5, which you can't even do because that would go over 10, but you get the general idea, is that if your standard deviation goes over or is really large compared to your total range, then it isn't a good representation and your mean is not a good representation. So it's all about context is what I'm trying to get at here, is that standard deviation tells you how clustered your data is around the mean, and the number doesn't mean anything. The standard deviation number doesn't mean anything unless you take it in context with the situation. So let's take into consideration, again, Kuelti and Zafron data. These are supposed to be commas. So I would like for you to input this data into your calculator. You see I've got mine to the side. I want you to input it again. I think this is going to be your third time putting it in. And for Kuelti and for Zafron, I would like for you to find the standard deviation. Now, remember that your standard deviation, okay, so it's how your data is clustered around the mean. So just looking at what we've done with the data so far, your assumption here, this is Coelti and this is Zafron, your assumption here is that Coelti is going to have a smaller standard deviation and Zafron is going to have a larger standard deviation because hers is less clustered, whereas Coelti's is very clustered. So going over to your calculator. So looking for the standard deviation, I'm going to go back over to table 1. This is for Mr. Coelti's information. You are looking for this symbol. You'll see this symbol right here. I'm totally blanking on the name of this symbol, but that is a Greek symbol, and that's the symbol that we use for standard deviation. And so your standard deviation for Coelti, we'll do to 2 decimal places, is 7.07, whereas with Zafron, if we go back over here and scroll down on our summary, we get 18.44. So a significantly larger standard deviation for Zafron than for Coelti. What we can then say from this information in regards, so okay, what do these numbers mean? Nothing unless it's in relation to the situation as a whole. Nothing unless we have it in context. In this context, this standard deviation means that the mean of Coelti's test scores are a good representation of the scores. So the mean is a good representation. Versus a relatively large standard deviation would say that the mean is not a good representation of the data. So you shouldn't be using the mean as a way to represent the data.